develop a commercial product using this one is probably not a good idea. This is for beginners or hobbyists, just trying to play with the very simple sensors and interfaces. So what's the goal of it? The goal is to develop a temperature sensor network for Fukuoka Springs hot tubs, and they have 24 hot tubs. And they don't want to run too many cables and traces or wires around the property because they want to maintain that, keep that natural view of it. And the water source for the hot tubs over there were totally from the hot springs. They don't have any heaters to heat it up, so they're pretty honest on that, right?
Do other ones have heaters?
I don't know,
oh.
But they definitely don't have any. So they have a big pipe which send all the hot spring to the hot tubs, and they have to manually turn on or off a cold water pipe to adjust the temperature, and they use their stuffed finger to test the temperature of it and see if it's at the right temperature, to dip the finger to the mixed water, in the hot tubs. So it's pretty natural, so you can definitely trust it. Is the water was not heated, the water was from the ground directly. But the downside is it's really not a modern, electrical, how to say that, or being automated by a computer system. It's just totally manual operations. And so hopefully they were trying to find out a solution to monitor the temperature instead of just manually change the temperature for each hot tub by their stuff. So they need 24 sensor nodes, and they have Wi-Fi on their property. So the only way to do it is send the signal through Wi-Fi instead of doing like Bluetooth, because the property is too big for Bluetooth. And any other solutions you can think of? Have you heard about any other IoT solutions? Microwave, so you're cooking the customers. There's another IoT technology. It's called LoRa. I don't know if I've heard about it. It's low power and long range. The LoRa protocol, I forgot the frequency of it. It's a low speed transmission. So if you are monitoring temperature, not streaming YouTube videos, it's good enough to use LoRa. And about 3 or 4 years ago, I have a student tested LoRa module, and I was in the college on the top of the 35 Hall building, and the student just drove away with another node of the sensor, and I think we were still able to receive and transmit signals after he drove away for 5 kilometers for 3 miles, 3.2 miles away. I can still receive signals. It's not being sent to any of the towers or the cellular signal at all, or satellite. It's directly wireless communication, which is amazing. But it's getting complicated because if you want to use LoRa, and so what is a hub? What's the server you want to use? That can be tricky. You can sense a signal, but LoRa is not Wi-Fi, right? You have to design a LoRa node hub first to receive all the LoRa signals to one, and then send it to another Wi-Fi module, and then eventually still send it to the servers through Wi-Fi. So eventually still have to go through Wi-Fi. So I just found out probably Wi-Fi will be the only solution for this kind of project. There might be another better idea, but it's low cost and easy to do as well. So by that time, I was looking for the modules that I can use. And I was pretty familiar with ESP8266, not 32 by that time, because 32 was not really popular, I think, at the moment. So we used Scroll down, I can see this is a ESP8266. It's from the same company. And the chip here is SoC, has a Wi-Fi's protocols in there, the digital blocks in there as well. But also it is a microcontroller. But we are not programming this guy as a microcontroller. You know, if you look at the pinouts, as power, RX, TX is a UART communication port, has a reset, has a channel enable, ground, not too many pins available on the module. But if you want to program it using Arduino IDE, it's compatible with it. Actually, you can program this guy to blink an LED, you know, to control something. It doesn't have too many pins, but it's a microcontroller. They're amazing. Only $2, $3 like that. We are not using this guy as a microcontroller, but we are just using this guy as a wireless module. You know what I mean? So the microcontroller will be the Arduino Nano, and everything will happen in that CPU over there. But when the data is ready, you send it to this module through UART. You send all the bytes to the UART module pins here, RX and TX. And this module, this chip here, it's a system on chip, has all the functionalities in there to convert the UART data into a wireless data, which is part you don't have to worry about. It's directly being processed by the module. That's why we are using the module instead of printing the antenna on the PCB ourselves. I never drew any antenna on the PCB. Yeah, you don't want to do that yourself. Okay, just directly buy a module and use it. So it's gonna send the data, collect the data in the form of bytes to a router through the antenna here. So this antenna will be able to communicate with the antenna of the router in the room. Just gonna send it out, and if you modify, you have to register account on ThinkSpeak. Just do that, and I think if it's just for a homework assignment, it's free. If you have to use it for commercial purposes, then it's about like $300 or $500 a year. It's not that expensive. So the Pokemon Spring hot tub is that property. If they want to use this the project we developed, then they have to pay the $300, $500 a year, which is nothing for them, pretty much. It's super cheap. Yeah, 2 nights or 1 night. I don't know. Yeah, they don't care about that. Yeah, at all. Okay. This is a really simple project, right? Probably for the people who haven't worked on this before, may take some time. But Mason reached out to me when he was doing the M&I lab, and I think I sent some of the tutorials to you during that time for the Raccoon project. So we have done pretty much everything, almost everything of it. You know, so after learn all the microcontroller stuff and PCB technology, just find out these projects are not that difficult as you thought. And making a PCB and building an embedded system from scratch, and they can eventually make a PCB and 3D print a case, and it can be used as a commercial product, can even sell it. Okay, and I can just let you know this simple project is a $10,000 contract. Yeah, it's very simple to the people who know how to do it. Right. You'll send it to ThinkSpeak, and so you can see the temperature over there. So this is option 1, right? And you can see I didn't put all the tasks as what I did for the company in here. So I simplified a lot of things. But you still have to make a PCB out of it. If you look at the breadboard version of it, right? It works for the OLED. You did it for the first project, which can be easier for you guys. But ThinkSpeak is a new thing, right? And I think I must have a tutorial on how to do it here. Scratch. Yeah, it's here as an example of it. Yeah, where's the here? Is that something I did? Yeah. So these are the ThinkSpeak stuff. So you can see the way I send it to the ThinkSpeak module, it's just a serial print, right? But if you search online like ESP8266, you can find millions of tutorials on it. But this is an example that I can directly use and make it work, right? Why I'm using a print. So when you send data to the serial monitor through the USB, what's the command that you use? Remember? Serial.print, right? You print it, then you see something on the monitor. So the connection between your Arduino board to the computer through the USB is actually just UART, serial communication, which is RX and TX. But there's an additional chip on the Arduino board will convert the RX and TX to USB. But that's something you don't have to worry about. You just need to know where is the RX, where's TX, and make the connections, and use the code here and do a serial print. So it's going to send the data through UART to another module, which has a connection with your Arduino board. Okay. And there are some other code here that are required to communicate with ESP8266 to send the data to ThinkSpeak. I think API is if you register account on ThinkSpeak, there will be a channel code or channel name. It's in the API. You have to change the API in order to do the communication. I think the API was defined here, right? So if you register account, you will see the API of your channel. You have to change it, replace it with yours. So now let's take a look at the circuit was what we had here. You have used a few different temperature sensors. So if you want to sense water temperature, what's the sensor you want to use? Think about the sensors. Yes, sir, Mr. Why? But you can easily get the two pins shorted. You have two metal pins. How do you protect it, right? So it's going to be a long cable, and it's going to the very tip of the cable will be the sensor, and you want to put it into the water, right? So first it has to be wrapped up by some material, like it's not conducting electricity, and also it's resistant to the mineral materials in the water as well. But still have to think about it, like why we don't use thermistors. What's the limitation of using a thermistor over there? A good part of this project is you have to think about all the practical or the real world setting in order to get a solution out of it. Why a thermistor is not a good solution here.
It's not so much about the complication. It's about making sure it can last and survive the heat the conditions. We're doing this thing with water. We have to modify this. The verses here quite a bit.
So thermistor is sending a wall signal. Analog. Yeah, sometimes the hot tops are not really at the edge, and you have access to every part of the hot top. They're just all get together, like 4 hot tops together. So a lot of times you need a long cable for the sensor. Yeah. If you have analog signal, what's the problem with X-bound phase shifting?
noise?
noises. It senses like 100 millivolts, and that millivolt, that voltage carries information of the temperature because it's an analog signal. So any noises will get into it and give you a lot of spikes to the voltage. You know what I mean? So here's the temperature data. If something comes in, you got noises like that, and that will be like 20 millivolts changes, or plus minus 10 Celsius degree, right? So for long distance transmission, do we want to send analog data through the long cable? No. So what you want to do, so the temperature sensor is sensing the temperature from like 10 feet away. You want to do what at the tip of the sensor? Yeah, you want to digitize it. Because if, for example, you got 1 point here, right? It's a temperature data, 1 point, and you convert it into a digital signal, like 8-bit digital signal, like 1 and zeros, whatever, you have 8-bit of it. So digital signal is more resistant to noise. Why is that? Why digital signal is more resistant to noise? It's only 1 or zeros. It's not like all these very small changes, right? It's either 1 or 0. So in that case, you probably prefer a temperature sensor that can digitize the digital signal right at the tip, and then directly send digital signal back to the microcontroller on at the other terminal of the cable. Okay, so the temperature sensor you have used, the ones you have used, which one will be a good fit here? That one has a thermistor in the middle. Yeah, but it has another chip to convert everything to digital. Yeah, that's right. But that temperature sensor has a plastic shield outside of it. That one is also analog. Yeah. So none of them is a good fit. However, luckily, there's an option from Dallas Semiconductor. I think this is one of their flagship product. It's called what's the name of it? DSB 18B20. This guy only has 1 wire to send the digital data. It's not standard digital communication. If you look at the pin outs, power, ground, and 1 data pin. Okay, and you connect it to a digital pin and use a library, it's going to receive the temperature data out of it. So this one will totally digitize the temperature outside of the inside the chip and directly send digital data after that. So this sensor works great. It's going to work for this purpose. And then I was trying to find out like how do we put wrap it into have another layer out of it, right? So we can protect it and also not shorting the pins, the metal pins here by the mineral, by the water. And I was lucky enough, so there was a product like this, long cable, and there's a what's the name of it? The 1820. So the 1820 chip is being put in here, but this is the metal cover of it. So there will be a problem because the mineral, it can be acidic materials in the water. Then it won't be a long-term solution, right? The long cable is good. You can directly get the power, ground, and data in the cable. And I kept searching online and eventually found out this one. It's also a 1820 chip. Look at the material. This one. It's rubber instead of metal. Best solution for this project. I directly ordered like 20. It works perfectly. So, but we, for this project, for you guys are not using this one cable. It's the same chip inside here, or the ones we have in the drawer. They're all the chips in here. This one's for the project. And now we got a solution for the sensor, right? And just starting from a very small step. Just sense the temperature first. Grab a nano board, make the connections. Just keep in mind that you have to put it up, so you have a single wire in the middle. It has to be put up to 0.3 volts. Very similar to I2C, but this one, it's not I2C protocol. And it's not I2C, that's why you don't have to use the I2C library just for this sensor. And what is this one? It's the OLED display you have used already. It's the I2C protocol to make the connections to the nano board. And so you can expect that you sense the temperature, use a sensor to sense the temperature and send it to the OLED display as the first task you want to make it work. Okay, show some temperature on the little module here, so you know that your nano works, your sensor works, and the OLED display works. And the next one is, so after you get the data, the next step should be like connecting the Wi-Fi module to the microcontroller. Okay, so this data was received by the microcontroller, and then you throw it to the Wi-Fi module, so then you are done with the project. Right? You just need to receive the data from the temperature sensor, display it on the local display, and send it to the router through the Wi-Fi module, so you can see the data on the SymSpeak as well. In the future, you can develop a GUI to receive, to get the data from the server and put it all the temperature from 24 hot tubs in one GUI. That's another step, the second step of it. But we don't have to do that one in this project. It's like a 2 weeks project. So the next one will be ESP8266. Do we still have port for that module? What was the connection? Do you still remember that? What are the ports? For this guy, right? Yeah. Do you have RxTX available? I think so, yeah. So still have it here. However, I think the interrupt that makes the I2C work may have a conflict with a one wire library for the 1820 temperature chip. That's why I have to use a second microcontroller. I just started adding one more microcontroller to it. Okay, it's not here. So this one. It's really not the best design you can have. So first I have a Arduino Nano here to sense the temperature data through the one wire using one of the digital pins. You can use any digital pin you want. Just change the name of the pin in the code accordingly. And at the same time, it sends the data to OLED display through I2C. And then I have to communicate with another Arduino Nano through SPI. So these are SPI ports. So the temperature data will be received by this guy, and I will have to send it to the second nano board. And the second nano board made the connection with a Wi-Fi module and send it out through Wi-Fi. So I think the conflict was not in between the one wire and the I2C. It was probably the I2C and the UART or something. Read through it, like see what the problem, what are the problems I had. I think I discussed it here. Okay. I really don't like the design because I have to use 2 microcontrollers, including the ESP8260. We have 3 microcontrollers to finish one simple project. It's not really good, right? So that's why ESP32 is great, because it's one microcontroller with multiple digital pins, like I2C. I think they have 2 at least, and 2 SPI and 2 UART as well, and also has Wi-Fi on it. You know, why not choosing ESP32 but choosing like Arduino? Okay, so this is one of the options you can follow. Okay, definitely if you just follow this tutorial and get a PCB out of it. So this is a final version, the breadboard version of it. It works really well. Okay, and then you did the same thing as what I did over here and convert it into the PCB and send it out for fabrication. So this will be the last PCB you are going to solder, but not the last PCB you are going to design. So there's another one after this, but this will be the last piece since we don't have time for the very last one for you guys to receive it and solder it. But this one we still have time. So I expect you guys to design the PCB, send it out, and solder it and test it, so you can get a really compact IoT module out of this project. Yeah. No, just the chip, not the board. What do you mean?
Right, just we need 2
Yeah.
chips on that.
Yeah. That's one of the options, right? It's not ideal, but if you just want to follow the tutorial and get it done, it works. But you can see the limitation of it. Okay. And you can see that I have another task here, add a push button or a few push buttons to the system to allow the user to change the Wi-Fi AP username and password. I think you can probably refer to the students' code in the past, see how they did it. Probably not everyone made it work by that time, because this can be a little, I didn't provide the code directly to you guys for this one. And I think the time I gave to you guys for this project is shorter than last year. So I think they had like 1 month to work on it. Now we only have like a little bit more than 2 weeks. So you can either refer to the whoever already did it in the past, just look at their reports, and or not doing it, just 10 points, right? It's not a big deal, I think. Okay. So another option, I'm going to provide a link to you guys as well. It's not directly in the on the course website. I think one of the students chose to use the ESP32, and that was a pretty successful attempt. Because I found out like we shouldn't have used 2 microcontrollers on one Wi-Fi module. Instead of doing that, we should use ESP32, which is more advanced, has everything in it, also has Wi-Fi, has Bluetooth. Just 1 microcontroller will do everything for the project. Okay, so he tried it, and it was successful. And I'm going to move forward with this technique for the project and directly deliver the results using the system, the schematic and PCB board in this report. So you can see the number of boards that he used on the breadboard is a lot less than the one I just showed you. It's only 1 ESP32 and 1 OLED, and I think the temperature sensor is a tiny one. So I think this is just the very first task to show something on the OLED. The temperature sensor must be somewhere here, I think. It didn't show it on this in this picture. And because this has a Wi-Fi module on it, so directly you can send the data through the router to ThinkSpeak, no problem. So you can see the data temperature is being displayed on ThinkSpeak. And so what's the best way to change the password or credentials of the Wi-Fi? The challenge actually from the customer. They told us on their properties, they change the Wi-Fi password every 6 months. Can you imagine we have 24 nodes and they're not programmable? They have to call me every 6 months to go there and grab an Arduino board and make all the connections and program it with a different password. Okay, that's usually how that works. They usually change the password in the public property, right? Hotels and all the resorts. You have to reprogram it. How do you program yourself?
It just checks it every 24 hours, or if it loses connection, it fetches it from ThinkSpeak and changes the variable.
Uh-huh. But the password is not on ThinkSpeak, right? How do you expect the password on ThinkSpeak? Any other solutions? How to do it? You can definitely. I'm pretty sure they need someone to do it, right? For example, if there's just one node, and you don't want to grab a breadboard and we do all the connections and change the password and username sometimes maybe. Just make it adjustable. I know it's still not the best option. So what we used is a encoder. So encoder, so he programmed a sub function in the microcontroller. So whenever you press it, you enter into the programming mode. And then you scroll this knob here to select all the from A to Z and 0 to, I don't know, 0 to 9 probably for each digit. And then you press it, so confirm that digit for that character in there. And you just keep moving to the next. It's still a lot of work. Yeah, that's going to be still a lot of work. But I was thinking, I was just telling like if we just have one, right? Then this is doable. And it's yeah, just program it, right? Yeah. I think eventually we still need to design the PCB like as a programmer. Definitely not the jumping wires on the breadboard. So awkward. Just maybe just design the like what you did last summer, right? Just make a customized PCB for a certain purpose, like bootloader, and we can design a certain specific PCB just for programming all the things. We program that one, but you want to make it really easy to use. For example, just one cable, like USB or something, so their staff can connect to it and just press the button. You design a little GUI, right? So what's the new password? What's the new username? Just put it in there and press it. But they are not actually dealing with all the Arduino IDE programming because they don't have that background. So don't let them change anything in the code. It's gonna be just a GUI with two spots. Like you can type your password and username in there and press OK. So it's gonna burn your Arduino with a new password and username. And then you use that one, you probably have to design a little push button on it, right? You make a very simple connection. It should be a few wires in the bus and very easy to use connector that we can directly plug into the board and push the push button. It's going to burn the code to it. That's probably what the final product should look like. But now I think this is a very good example to learn, I think, because when I was programming the Wi-Fi, changing the Wi-Fi credentials for my printer, it doesn't have a keyboard on it, so it has a push button. So what I did was I have to use a push button to push through like A to Z and 0 to 9, and including like uppercase and lowercase Yeah, in order to find out the right one to use for that digit. If you have a long password, it takes like a few minutes to do it. But I think this will be better than the push button. So if you know how to do it, if you get into the company or the brother printers company, you can promote this technology instead of using a push button, just design a little knob on it, and it's way easier. So I think that's a good thing to learn, like how you can change the Wi-Fi credentials without reprogram the microcontroller through USB. You just directly change the credentials and you confirm it, and then it's going to make the new connection. Okay, very good example to learn, I think. Super practical. Even though it's still not a final product, because there's stuff to do that for 24 nodes, 5 minutes for each every 6 months. It's not a good idea, but this is option 2, right? You can either follow the one here or follow this one. I'm going to send you the link to everyone after this lecture. And that's the final PCB. And that's the one we used for the poster. If you could probably already see the poster outside. Exactly the same product. I think Kelvin didn't change the PCB. He designed the GUI out of it. And I can show you really quick. So that's the PCB. And this is a little display. And it's able to communicate with the router and with the ThinkSpeak through the router. And now let's look at the GUI. So Kelvin worked on this one last summer, and it was programmed in PyQt. It's API for Python for GUI design. So this was a program he designed with all the push buttons and the function. Here is plot, export, and also it's displaying the temperature for each node in real time. And if you press this push button, it's gonna, if you click it, it's gonna plot it here, plot the data here. And if you export it, it's gonna export the data in the Excel file for post-processing. And these are the detailed instructions of how to build that GUI in Python. It's already working, so you can follow it and make it work and make an exe file that I can sell on your website. I don't know who's gonna buy it, but this is a really awesome project, isn't it? I think it's almost 190 something percent there, I think. We just need a company to promote it and post it on the website, right, Mason? Your company will be started in 2 months or something. Yeah. So this can be one of the products we can use, right? The oximeter, the temperature sensor, and also the last one we are going to work with, which is the horseshoes project here. It's an ESP32, but on a very compact PCB board as a final PCB design. But we are not going to fabricate it. But you guys still have to go through the entire process and get layout done. Yeah, so this chip is the most difficult chip to solder, the most difficult one I had in my life to solder, this voltage regulator. So this is not the ones you have used, right? You got the 1 amp and 3 amp regulators. These are just regulators you can find anywhere. It's very common one, popularized well, but they are not really compact. Definitely you don't want to use one of these ones on this board because we don't have that much space for the horseshoes. So I have to use something like, as this one has a very, very low dropout voltage because we only can have one LiPo battery cell can be fit into the shoe, which is 3.7 volts. But the ESP32 requires 3.3 volts. So usually the regulators have a dropout voltage, which means when they regulate the voltage to a certain value, they will lose like usually 1 volt. So if you have like 3.7 volts from the power source from the battery, and if you use a regular, the ones we have used, it's going to lose 1 volt out of it. So you are getting 2.7, which won't power up your ESP32. So to find a really advanced one, has a low dropout voltage, which means after the it's getting regulated, you are not losing too much voltage out of it. I think this one has a dropout voltage of 300 millivolts. So if you have like 3.7 after losing 0.3 volts, you're getting like 3.4 volts. That will make it work. It took me a very long time to find out the right one here for this project. And definitely it's not a cheap one. It's pretty expensive. And the good thing is it's very tiny. So can fit into this board perfectly. But the downside is super difficult to solder. And when you are laying out, because there's no way that I can find it in the SparkFun library. Not many people are using it. So when you design the footprint of it, you have to change the grade to a very fine grade in order to get the paths into the layout design. I have to change the grade back after you switch back to this one. But when you are designing the customized library for this guy, you have to use a very fine grade for it, or pressing the Alt key on the keyboard, right? That's the accelerometer, gyroscope. So this one, probably for you guys, this is already pretty difficult to solder, but if you compare, this is way more difficult. I can tell you, like, if I solder this guy, use a argon, if I solder 10, probably I can get 9 to 10 functioning, no problem. When I solder it, okay? If I solder this guy, I think if I solder 10, only 6 will work. Okay. What did you mean by that? I don't think they have this module. They have this chip in their company. They probably don't have it. Yeah. Could be expensive to do a chip like this on the board. Okay, so I think if you have to rate the difficulty level of soldering the surface mount, so for the Arduino Nano surface mount chip, like you guys have been soldering, right? That's probably difficulty level 2. And this one is probably difficulty level like 6. And this will be 9. Right? Just give you some heads up. All right. So the sensors are here. Right? The temperature sensors are here. If you need a more nano board, find in the board as well. Let's see. Wednesday the 19th, 2 weeks from now.